Welcome to Dreaming Through Knowledge. Tonight, we embark on a journey that transcends the boundaries of our daily lives, moving not across physical space, but drifting through the deep, silent currents of time. We travel far back, peeling away the layers of history, past the rise of human civilizations, past the freezing grip of the ice ages, to a world that feels both alien in its majesty and strangely familiar in its rhythms. We arrive at the final days of the dinosaurs. This is not a story rooted in fear, nor is it a tale focused solely on destruction. It is, at its heart, a story of profound transformation. It is the chronicle of the end of one magnificent version of our planet, and the quiet, seeding ground of another. It is a testament to the resilience of life itself, playing out on a planetary scale that dwarfs our imagination. 66 million years ago, Earth was a planet warm, verdant, and teeming with a vitality that is difficult to conceive today. It was the very end of the Cretaceous period, a geologic era defined by biological abundance and extremes. The continents were drifting slowly toward their modern positions, tearing apart the ancient supercontinents, but they were not yet quite settled. High sea levels, fed by a warm climate and lack of polar ice, created shallow, sun-drenched inland seas that divided land masses, creating isolated pockets of evolution where life could experiment in wild and wonderful ways. The climate was tropical and humid, a global greenhouse where the poles were entirely free of ice. If you were to stand in what is now Antarctica during this time, you would not see blinding white snow or feel the biting wind of a frozen desert. Instead, you would stand amidst a lush, temperate rainforest, surrounded by ferns and ancient conifers, listening to the rustle of creatures in the undergrowth. The planet was a jewel of green and blue, breathing in a rhythm that had sustained it for millions of years, a paradise of warmth. Forests stretched across the planet like a living, breathing quilt, wrapping the globe from the equator to the high latitudes. These were ancient forests, filled with the heavy scent of pine resin, damp earth, and the decay of organic matter that feeds new life. Palm trees, with their broad, fanning leaves, grew in places that are now locked in permafrost. Sunlight filtered through a canopy that seemed endless, dappling the forest floor where the drama of life played out in silence and shadow. But there was something new here, too, a revolution in the plant kingdom. Flowering plants, the angiosperms, had only recently appeared in the grand timeline of Earth. They were painting the world with new strokes of color. Soft pinks, vibrant yellows, and vivid reds were beginning to dot the landscape of endless green. With these flowers came new scents, sweet and heavy in the humid air, attracting the ancestors of modern bees and butterflies. The world was becoming a sensory tapestry, more complex and vibrant than ever before. The dinosaurs ruled this world completely, with a dominance that seemed unshakable and eternal. For more than 150 million years, they had been the undisputed masters of the land. They had adapted to every conceivable environment, evolving into forms that defy our modern imagination, conquering the deserts, the forests, and the swamps. Imagine the giant sauropods moving like living mountains through the fern-covered plains. These titans, such as the Alamosaurus, with necks that reached high into the canopy, were the largest animals to ever walk the earth. Their movement was slow and deliberate, a terrestrial ballet of immense weight and power. As they walked, the ground would vibrate, a low-frequency thrum that could be felt miles away, the heartbeat of the Cretaceous landscape. Their skin was thick and leathery, scarred by time and covered in dust, a landscape unto itself. Beneath them, in the shadows of these giants, small feathered hunters darted through the underbrush. These were the raptors, intelligent and swift, their feathers displaying patterns of camouflage to blend with the ferns, or bright colors for display. They were the ancestors of birds, sharp-eyed and quick, living in a complex society of their own. They remind us that the line between dinosaur and bird is a blur, a gradient of evolution that was already well underway long before the end came. In the oceans, the dominance of reptiles continued in a terrifyingly majestic fashion. Great mosasaurs, some as long as school buses, swam with powerful rhythmic strokes of their tails. They navigated waters teeming with life. Spiraled ammonites that floated like jewels in the water column, ancient sharks patrolling the reefs, and vast clouds of glowing plankton that illuminated the night seas like a reflection of the Milky Way. The ocean was a dangerous, beautiful realm, a mirror to the richness of the land. Above, the skies belonged to the pterosaurs. These were not birds, nor were they dinosaurs, but flying reptiles of extraordinary design. Some were as small as sparrows, flitting between branches catching insects. Others, like the Quetzalcoatlus, were the size of giraffes, launching themselves into the air with powerful limbs to glide on warm thermal currents. Their wings, made of stretched skin and muscle, caught the sunlight, light that had traveled across the vacuum of space from the same sun that warms our faces today. From their vantage point high in the atmosphere, they looked down upon a world that was full. Every ecosystem was saturated. Every biological niche was occupied. Evolution was in full bloom, a masterpiece of biological engineering that had been refining itself for eons. Life on Earth had reached a delicate, intricate balance. The herbivores kept the forests in check, pruning the vegetation. The carnivores kept the herds strong, removing the weak. The cycle of nutrients, from the soil to the plants to the animals and back again, flowed without interruption. It felt eternal. To any observer, it would have seemed that this age of giants would last until the sun itself burned out. But far beyond the blue sky, far beyond the protective embrace of the atmosphere, on the cold outer edges of the solar system, something was moving. It was a silent traveler, a fragment of rock and metal left over from the chaotic birth of the planets 4.5 billion years ago. It was a ghost from the dawn of creation. For eons, it had drifted in the dark void, one of countless debris fields orbiting the sun. It was a relic, a time capsule frozen in the vacuum. It was about 10 kilometers wide, a size that is difficult to comprehend. Small compared to the planet Earth, a mere speck in the solar system, yet massive enough to hold kinetic energy beyond human calculation. Its path was silent, invisible, and, due to the laws of celestial mechanics, unstoppable. Astronomers today, looking back with computer models and mathematical proofs, can trace its likely origin to the asteroid belt between Mars and Jupiter. Or perhaps it came from even farther away, from the icy Oort cloud, nudged by the gravity of passing stars or the giant planets. For millions of years it tumbled through the vacuum, a lonely, cold stone, utterly lifeless. It passed through the emptiness between worlds, unaffected by the dramas of life evolving on the blue planet nearby. It had no intent. It had no malice. It was simply matter in motion, obeying the laws of gravity, dancing a cosmic waltz that would eventually lead to a collision. And then, in a single, fateful moment of cosmic alignment, the orbit of Earth and the trajectory of this rock intersected. It was a collision course set in motion long before the first dinosaur hatched. As the asteroid approached, it remained invisible to the creatures below. There were no telescopes to spot it, no warnings to sound, no mathematics to predict its arrival. When it finally entered the Earth's influence, it was traveling at a staggering speed, more than 70,000 kilometers per hour. To put that in perspective, it is a speed that allows you to cross entire continents in minutes. At that velocity, the atmosphere, which usually acts as a shield for our planet, burning up smaller meteors, could not move aside fast enough. Time freeze. The air in front of the asteroid was compressed instantly. This compression generated heat so intense that the rock began to glow. It became a fireball, creating a trail of light brighter than 1,000 suns. It tore through the sky, a second sun appearing out of nowhere, casting harsh, moving shadows across the landscape, turning the blue sky to a blinding white. But before we reach that moment of impact, let us pause. It is worth slowing down our mental time machine to truly understand the world that awaited this visitor. Let us zoom in on North America, the stage where this drama would be most intense, to appreciate what was about to be lost. The North America of the late Cretaceous was not the continent we know today. It was physically divided. A vast inland sea, known as the Western Interior Seaway, cut the continent in two, connecting the Arctic Ocean in the north to the Gulf of Mexico in the south. It was a shallow, warm sea filled with sediment and life. To the west of this sea lay Laramidia, a land of rising mountains, the ancestors of the Rockies. These peaks were young and sharp, pushing up from the crust due to tectonic forces. To the east lay Appalachia, older and more weathered. Between the mountains and the sea lay lush floodplains, deltas, and swampy forests teeming with life. A landscape similar to the modern Amazon or the Everglades, but on a grander scale. This was the home of the most iconic dinosaurs of our imagination. Here, herds of Triceratops grazed on tough palm fronds and cycads. They were social animals, communicating with low rumbles, their magnificent frills flushing with color to signal dominance or attraction. They moved through the landscape like buffalo would millions of years later, shaping the environment as they fed. Stalking through the shadows of the conifers was the Tyrannosaurus rex, not a mindless monster, but a sophisticated apex predator. It had binocular vision, an acute sense of smell that could detect prey from miles away, and a brain larger than any dinosaur before it. It was a creature perfectly adapted to its environment, raising its young with care, ruling its territory with absolute authority. We can imagine a T-Rex parent gently nuzzling its offspring, a moment of tenderness in a brutal world. Between the feet of these giants, countless smaller species lived. There were lizard-like reptiles basking on rocks, early snakes slithering through the leaf litter, and amphibians croaking in the muddy banks of slow-moving rivers. The air was rich with oxygen, denser than it is today, allowing insects to grow large and fill the air with a constant humming drone that served as the soundtrack of the afternoon. Thunderstorms rolled across these plains with spectacular power, feeding the endless greenery. The rain was warm, washing over the scales of the dinosaurs and the petals of the first magnolias. Birds, direct descendants of smaller theropod dinosaurs, had already begun to diversify. They filled the skies with new songs, a prelude to the avian chorus we know today, flitting between the branches of trees that would look familiar to us: oaks, willows, and magnolias. It was, by all accounts, a thriving, noisy, colorful world. It was a world of mothers tending to nests, of predators hunting for survival, of the sun rising and setting on a planet that had found a stable, enduring rhythm. It was a world that made sense to those who lived in it. And in that world, no creature could have possibly sensed the approach of what was coming. The concept of an asteroid did not exist. There was no intuition for threats from above. There was no sound carried from the vacuum of space to warn them. The universe was silent, even as the hammer was falling. Just the normal rhythms of life continuing beneath the clouds. A T-Rex napping in the shade, digesting a meal. A dragonfly landing on a fern, its wings shimmering. The waves of the inland sea lapping gently against the shore. It was a Tuesday or a Friday, just another day in the deep stream of time. Then, on that seemingly ordinary day, the silence was broken. The asteroid entered the upper atmosphere. The physics of this event are almost too extreme to visualize. It would take only seconds, mere heartbeats, for the rock to fall from the edge of space to the ground. At first, for those directly below in the Yucatan region, the sky would have changed. A point of light appeared, growing rapidly into a blinding sphere. It was a hole punched through the atmosphere, dragging a tunnel of vacuum behind it. The light was so intense, it would have instantly charred skin and blinded eyes before the rock even touched the water. The shadows on the ground would have become razor sharp. The asteroid struck the shallow waters near what is now the Yucatan Peninsula in Mexico. When it made contact, the energy released was incomprehensible. It was equivalent to more than 10 billion Hiroshima bombs detonating simultaneously. The crust of the Earth buckled under the blow. In that fraction of a second, the asteroid itself was vaporized. It didn't just break. It turned into gas and plasma instantly due to the sheer force of impact. The bedrock beneath the sea behaved not like solid stone, but like a liquid. It splashed upward, creating a mountain of rock higher than Mount Everest for a brief moment, before collapsing back into a crater, rippling the Earth like a pebble dropped in a pond. The crater it left behind, the Chicxulub crater, stretches more than 180 kilometers across. Even today, it lies buried beneath kilometers of limestone and ocean sediment, a hidden scar beneath the turquoise waters of the Gulf of Mexico. It is the fingerprint of the apocalypse, preserved in the crust of the Earth, a silent memorial to the power of the cosmos. The immediate effects were localized but absolute. The impact vaporized everything within hundreds of kilometers. Water, rock, and life were turned into superheated steam and dust. A shock wave raced outward at speeds defying imagination, flattening forests as if they were matchsticks, scouring the land clean, stripping the earth to its bones. But this violent moment is not the whole story. If the damage had stayed local, the dinosaurs might have survived. The Earth is large and life is stubborn. However, the violence of that day was only the trigger, the beginning of a much longer global transformation that would touch every corner of the globe. When the asteroid hit, it blasted billions of tons of earth and rock back up into space. This debris, known as ejecta, did not stay there. It orbited the Earth briefly, a deadly halo before raining back down through the atmosphere. As these trillions of tiny rocks re-entered the atmosphere all over the world, they burned up like shooting stars. The sky was filled with fire, horizon to horizon. The friction raised the temperature of the atmosphere globally. For a few hours, the surface of the Earth became an oven. Forests far away from the impact site, on the other side of the world in Asia and Antarctica, spontaneously ignited. Global wildfires consumed the vegetation that had supported the dinosaur food web. Smoke, soot, and ash rose up, joining the vaporized rock and sulfur that the impact had thrown into the stratosphere. A thick, choking curtain was drawn across the sky, sealing the planet in darkness. The brightness that had defined life for millions of years dimmed. The sun, the engine of all biological energy, was blotted out. Day turned to a murky, gray twilight. This darkness would last not for a week, but for months, perhaps years. The stars were hidden. The moon was gone. Only the red glow of dying fires illuminated the ground. With the sun blocked, photosynthesis stopped. The plants, those lush ferns and towering palms, began to wither and die. The food chain was cut at its very base. The herbivores, unable to find enough food in the ash-covered landscape, began to perish. The carnivores, deprived of their prey, followed soon after. The Great Silence had begun. Temperatures plummeted. The greenhouse world of the Cretaceous was plunged into an impact winter. Though tropical forests froze, the shallow seas cooled. Rain turned acidic as the sulfur from the vaporized rocks mixed with water vapor in the clouds, falling as a toxic drizzle that altered the chemistry of the oceans, dissolving the shells of microscopic life. It was a dismantling of the world, piece by piece. The great dinosaurs, specialized for a warm, food-rich environment, could not adapt to this sudden, brutal cold and hunger. Their size, once their greatest advantage, became their downfall. They needed too much food, too much energy. They were masterpieces of a world that no longer existed. And yet, even in the midst of all this cataclysm, even as the great reptiles faded into history, life endured. This is the miracle of the story. Life did not vanish. It hid. It hunkered down. It waited. It found a way to persist in the margins. Deep in burrows, underground where the heat of the fires could not reach, small, furry creatures survived. These were the early mammals, shrew-like animals, scavengers, generalists. They could eat almost anything: insects, roots, decaying matter. They were small enough to need little food, and their fur kept them warm in the cooling world. They huddled together in the dark, listening to the wind howl above. In the oceans, while the great marine reptiles and ammonites died out, deep-sea dwellers, sharks, and some species of turtles found refuge. In the freshwater rivers and lakes, crocodiles and amphibians managed to persist, protected by the thermal stability of the water and the detritus-based food chains. They became the living fossils we see today. And in the soil, seeds waited. Seeds are incredible biological capsules, capable of remaining dormant for years, holding the potential of a forest inside a tiny shell. They lay in the dark, cold earth, waiting for the signal that the world was safe again. They were the promise of a future spring. When we look at this event through the lens of science, it becomes a story of balance. A cosmic balancing act of destruction followed by rebirth. The Earth, though struck and shaken to its core, began to heal. It is a planet that knows how to repair itself, given enough time. Slowly, over years and decades, the dust began to settle. The acid rain ceased. The sun, that old friend of life, broke through the thinning clouds. The air cleared. The warmth returned. And where the forests had burned, green shoots began to push through the ash. The resilience of life asserted itself once more. Ferns were the first to return, carpeting the healing world in green, stabilizing the soil. Then came the flowering plants, exploding back into life with renewed vigor. The ecosystems rebuilt themselves, but they were different. The cast of characters had changed. The stage was set for a new play. It is easy for us to think of this day, the day of the asteroid, as an ending, and indeed it was an ending for the non-avian dinosaurs. But in truth, in the grand narrative of Earth, it was a beginning. It was a reset button pressed by the universe. The extinction of the dinosaurs opened up space. The world was no longer dominated by giant reptiles. There were empty niches waiting to be filled. This vacuum allowed the mammals, our ancestors, to rise. They emerged from their burrows into the sunlight. They grew larger, more diverse. They evolved into whales, into horses, into primates. Without that asteroid, without that precise moment of impact, the evolutionary pressure that led to the rise of intelligent apes, and eventually to us, might never have existed. The dinosaurs might still be ruling the planet, and we would be nothing more than a possibility that never happened. We are the children of this catastrophe. Every ending in Earth's history carries within it the seed of a new creation. The universe destroys, but it also builds. The asteroid did not destroy life. It changed its direction. It nudged the path of evolution onto a new track, one that would eventually lead to consciousness, to art, to science. In this way, the story of the dinosaurs is also the story of us. We are here because they are gone. Their tragedy paved the way for our triumph. The atoms that make up our bodies have been part of this planet through it all, through the heat, the cold, the impact, and the recovery. We share a heritage with the T-Rex and the Triceratops. So, as we look back on that violent day, 66 million years ago, we do so not with fear, but with a sense of connection and gratitude. We honor the creatures that came before us, the giants that shook the ground. We recognize their reign was long and successful, and their end was not a failure, but a cosmic accident. The story reminds us that even the greatest disruptions can give rise to beauty, that from loss, new forms of life can emerge, unexpected and wonderful. It teaches us that resilience is the fundamental rule of nature. Life always finds a way to continue, to adapt, to flourish. When we walk under the stars tonight, take a moment to look up. We are looking at the same sky that once watched over the Triceratops and the Tyrannosaurus. Somewhere out there, in the silence of the solar system, fragments of that ancient asteroid family still drift in orbit. They are silent witnesses to Earth's resilience, drifting in the peace of space. The planet beneath our feet has endured much more than we can imagine. It has been frozen, burned, struck, and reshaped, and still it turns. Still, the seasons change. Still, life finds a way to bloom. The Earth is a survivor, and we are its passengers. We leave the Cretaceous now, letting the dust settle in our minds. The fires have burned out, the ash has settled, and the long recovery has begun. But the story is far from over. The mystery of this event runs deeper than just the impact itself. In the next chapter, we will move from the dramatic to the detective work. We will journey deeper into the science of the impact. We will discover how geologists learn to read the thin layers of clay that tell this story, how they found the smoking gun buried in the ocean floor, and how we know, with such precision, exactly when the world changed forever. For now, let your mind drift back to that ancient world one last time. Imagine it warm, green, and full of sound. Picture the sunlight filtering through the palm leaves, and see the moment the sky opened, not as the end of life, but as the spectacular, fiery beginning of the chapter that includes you. Rest now in the knowledge that the Earth endures and the story continues. The moment of impact lasted less than a heartbeat. In the grand, sweeping narrative of the cosmos, it was a fraction of a microsecond, a blink of an eye that should have gone unnoticed. Yet, the consequences of that single, fleeting moment echoed across the canyon of time for millions of years, shaping the destiny of every living thing that would ever walk, swim, or fly upon this earth. It is difficult for the human mind, accustomed to the slow ticking of seconds and minutes, to comprehend the sheer violence of geological suddenness. We are used to mountains rising over eons and rivers carving valleys over millennia. But this was different. This was the universe, asserting its chaotic power in a singular instant of transformation. When the asteroid, a rock larger than Mount Everest traveling at cosmic speeds, struck the shallow waters of the Yucatan Peninsula, the laws of physics, as we experience them, seemed to suspend. The surface of the Earth, solid and ancient, behaved like a liquid. Imagine dropping a stone into a pond. You see the water splash up, the ripples spread out, and the center recoil. Now imagine that water is solid granite and limestone. Upon impact, the bedrock didn't just crack, it flowed. Rocks rose and fell in waves taller than the Himalayas, freezing in place only moments later as the energy dissipated. The sea itself was lifted into the upper atmosphere, instantly vaporized by the friction and heat, only to rain back down hours later as a boiling, saline mist. For a few terrifying minutes, the sky above North America was brighter than the sun. The friction of the asteroid tearing through the atmosphere created a tunnel of plasma, superheated gas, that radiated an intense, blinding light. It was a light that would have cast sharp, stark shadows before evaporating anything it touched. Then, as the initial fireball rose into the stratosphere, mushrooming outward into the vacuum of space, a profound change began. The brightness faded, replaced by an ominously spreading gloom. Darkness began to grow, stretching its fingers across the horizon, a shroud being pulled gently but firmly over the dying world. Geologists today call this cataclysm the Chicxulub Impact. The name comes from a small, unassuming town in Mexico, located near the center of the buried crater. In the Mayan language, Chicxulub roughly translates to the flea of the devil, a coincidence of naming that hints at an ancient, perhaps subconscious memory of a scarred land. Its diameter, about 180 kilometers, makes it one of the largest confirmed impact sites on our planet. It is a scar so vast that you cannot see it from the ground. To stand in the center of the crater is to see only flat, scrubland, and ocean. The rim lies beyond the horizon, hidden by the curvature of the Earth itself. For years, its existence was completely unknown to science. The crater lay hidden beneath kilometers of thick limestone sediments, deposited over millions of years, and covered by the turquoise waters of the Gulf of Mexico. The Earth had bandaged its own wound so well that we walked upon it without knowing. Only in the late 20th century did scientists begin to connect the scattered dots of evidence. It started with anomalies, whispers in the data. Oil prospectors noted unusual magnetic readings. Then, satellite imagery revealed a strange, perfect semicircle of sinkholes, known as cenotes, on the Yucatan Peninsula. These freshwater pools, sacred to the Maya, were actually tracing the fault lines of the crater's ancient rim. But the smoking gun, the key that unlocked the mystery of the dinosaurs' disappearance, was found thousands of miles away from Mexico. It was found in a layer of clay so thin you could pinch it between your thumb and forefinger. This thin layer, just a few centimeters thick, marks the physical boundary between two worlds, the end of the Cretaceous period and the beginning of the Paleogene. Geologists call it the KP boundary. It can be found in exposed rock faces from the limestone gorges of Italy to the Badlands of North America, from the cliffs of New Zealand to the coasts of Greenland. To the naked eye, it looks like a simple band of dark dirt sandwiched between layers of lighter rock. But inside it lies a secret message from the cosmos. It contains a staggering concentration of a rare, silvery white metal called iridium. On Earth, iridium is incredibly scarce. It is a heavy element, and when the Earth was young and molten, almost all of its iridium sank deep into the core, locked away in the planet's iron heart. You are more likely to find it in a wedding ring than in a scoop of garden soil. But in meteorites, and in the wandering asteroids of our solar system, iridium is common. It remains abundant in the primordial debris of space. The discovery of that global iridium layer, made by the father and son team Luis and Walter Alvarez in 1980, was a revelation. It was the first solid, chemical evidence that the extinction was not a slow, gradual decline, but a sudden, violent event caused by a visitor from the stars. It was a radical idea at the time. Science prefers slow processes, evolution, erosion, drift. But the iridium layer forced us to accept that sometimes history changes in a single beat. Since that discovery, every fragment of rock analyzed, every drill core pulled from the ocean floor, has added detail to the story. It is a story we can now tell, almost moment by moment, reconstructing the apocalypse with the precision of a crime scene investigation. In the seconds after the impact, a crater deeper than Mount Everest is tall opened in the Earth's crust. The asteroid punched a hole through the atmosphere and deep into the mantle. For a moment, the Earth's interior was exposed to the vacuum of space. Temperatures near the center exceeded several thousand degrees Celsius, hotter than the surface of the sun. The rock did not just melt, it dissociated. The atmosphere nearby ignited, burning with a ferocity that defies description. The water of the shallow sea was flashed into steam, expanding with explosive force that added to the cataclysm. A massive shock wave raced outward from the blast zone. It was not merely a wind. It was a wall of compressed air moving faster than the speed of sound. It flattened forests within 1,000 kilometers instantly, snapping the trunks of giant conifers like dry twigs. Winds reached speeds faster than the strongest hurricanes recorded in human history, carrying debris, ash, and fire across continents. The roar of this wind would have been deafening, a sound so loud it was felt physically, vibrating through the bones of any creature unfortunate enough to be near. But the destruction was not limited to the ground. Billions of tons of rocks and molten glass were thrown upwards, ejected into the suborbital flight of space. For a brief time, the Earth had a ring of debris like Saturn, but gravity is a relentless master. This debris fell back through the atmosphere. As these trillions of particles re-entered, friction heated them until they glowed white-hot. It was a rain of fire. The collective heat from these falling shooting stars heated the atmosphere globally. It turned the sky into a broiler oven. For several hours, the surface temperature of the planet spiked dangerously high. In North America, closest to the blast, nearly everything on land was set alight. Spontaneous forest fires erupted across the continent, consuming the lush vegetation of the Cretaceous. The smoke from these fires joined the dust in the atmosphere, thickening the veil. Yet in distant places on the far side of the world, such as Antarctica or ancient New Zealand, the effects were delayed. The first sign was light, an eerie, dim orange glow that spread across the night sky, growing brighter and brighter as the ejecta rained down. The animals there would have looked up, confused by a sky that seemed to be burning without sound. Hours later, the ground began to move. The impact was so powerful that it rang the earth like a bell. Seismic waves of a magnitude never experienced by humans, perhaps magnitude 11 or higher, traveled around the world. These waves circled the globe multiple times, triggering landslides, volcanic eruptions, and earthquakes thousands of miles from Mexico. The planet was shuddering, its tectonic plates jostled by the blow. Then came the water. The energy of the impact displaced the ocean, creating tsunamis of unimaginable scale. Waves hundreds of meters high, walls of dark water moving at the speed of a jetliner, raced across the ancient oceans. They crashed into the coastlines of what is now Texas and Florida, rushing hundreds of kilometers inland, scouring the earth down to the bedrock, dragging forests and dinosaurs back into the deep. Even in distant ocean basins, the sediment on the seafloor was stirred up, erasing the history of millions of years in a chaotic swirl of mud. And then, after the noise, after the fire, after the water, came the silence. A silence so profound it felt heavy. The chaotic energy dissipated, leaving behind a broken world. A darkness thicker than night descended. The dust from the pulverized rock, the soot from the global wildfires, and the sulfur released from the vaporized gypsum beds of the Yucatan filled the atmosphere. They formed an impenetrable aerosol cloud that wrapped the entire planet. From space, had anyone been watching, Earth would have appeared not as a blue marble, but as a faint, dull sphere. Its oceans and continents hidden beneath swirling clouds of gray ash and black smoke. The jewel of the solar system had lost its shine. The sun, the giver of life, vanished for months. At noon, it was no brighter than a moonlit night. Without light, the engine of the biosphere stalled. Photosynthesis, the chemical miracle that converts sunlight into energy, stopped completely. Plants withered, their leaves turning brown and falling into the ash. The microscopic phytoplankton in the oceans, the base of the marine food chain, died off in mass numbers. The food web began to collapse from the bottom up. The great herbivores, the triceratops and the hadrosaurs, wandered through a dying landscape, finding nothing but charred remains. Starvation set in quickly. The predators, the tyrannosaurs and the raptors, feasted on the dead for a time, but soon they too faced a world without sustenance. The cold, dark winter had arrived. In the fossil record, this moment appears as a sharp, brutal boundary. It is a line in the sand of time. Below the iridium layer, the rock is full of pollen, spores, and the fossilized bones of a thriving, diverse ecosystem. Above it, the rock is silent. Many species are simply gone. They vanish from the pages of history. Scientists estimate that about 75% of all species on Earth disappeared in this single event. 3 out of every 4 types of plants and animals were extinguished. It was not the largest extinction in Earth's history. That grim title belongs to the Permian extinction, the Great Dying, some 250 million years earlier. But the Chicxulub event was perhaps the most transformative. It was a pivot point. It ended an era of reptiles and began the era of mammals. Still, even in those dark, freezing months, life held on. This is the most important part of the story. Life is tenacious. It clings to the edges. Small mammals survived. They were creatures no bigger than rats or shrews, overlooked by the giants of the Cretaceous. They possessed key advantages. They could burrow deep underground, escaping the heat and the cold. They were scavengers, able to eat insects, roots, and decaying matter, food sources that were still available in the dark. And they had fur, a warm coat to insulate them against the impact winter. In the waters, crocodiles and turtles endured. Their aquatic habitats acted as a buffer against the extreme temperature swings. Their slow metabolisms allowed them to go for long periods without food. They lay in the mud, waiting, slowing their heartbeats, outlasting the apocalypse. And the birds, the only lineage of dinosaurs to survive, carried the legacy of flight into the future. While their larger cousins perished, these small, beaked theropods survived, likely because they could eat seeds. Seeds are durable. They can persist in the soil for years, little batteries of energy waiting to be unlocked. The oceans, though devastated, slowly began to recover. Deep-sea creatures, shielded from the worst surface changes by kilometers of water, continued their slow, steady existence in the eternal dark of the abyss, largely unaffected by the drama above. As the dust settled, gravity slowly cleared the sky. Sunlight returned, first dimly, a gray dawn that lasted for weeks, and then brighter. The sun broke through the clouds, touching the surface of the earth for the first time in years. Rain washed the air clean, scrubbing the dust and soot from the atmosphere. The temperature began to rise again. The impact winter gave way to a period of global warming, as the carbon dioxide released by the fires trapped the returning heat. The climate would remain unstable for thousands of years, swinging like a pendulum before finding a new equilibrium. But within a few decades, a blink of an eye geologically, the Earth was green once more. The recovery is written in the rocks, just above the layer of death. After the iridium layer comes another distinctive band, a thin stratum of clay rich in fossilized fern spores. Paleobotanists call it the fern spike. It is a global phenomenon. Ferns were among the first plants to return after the fires. They are the pioneers of the plant world. Their spores are light, carried on the wind to the farthest corners of the globe. They can grow quickly in ash-rich, nutrient-poor soil. Imagine a landscape of black charcoal and gray mud, and then suddenly, the vivid, electric green of unraveling fern fronds. In a sense, they were Earth's first responders, the vanguard of life returning to a devastated zone. They laid the groundwork for the forests to return. Within 100,000 years, the canopy had closed again. Forests of palm and pine stood tall, and with them came new species adapted to the changed world. The stage was reset, the props were new, and the actors were changing. What is most extraordinary about this recovery is its resilience. We often think of the Earth as fragile, but in the long view, it is incredibly robust. The same planet that endured an impact strong enough to melt rock was able to heal itself through the slow, blind persistence of biology. This resilience is one of Earth's defining features. It is a survivor. Over billions of years, our planet has faced asteroid strikes, volcanic winters, shifting continents that tear apart oceans, and ice ages that freeze the globe solid. And yet, each time, life has found a way forward. Life flows like water. Block it here, and it finds a new channel there. The story of the dinosaurs' extinction is, therefore, not simply a story of destruction. It is a story of transformation. It is the story of how an ending makes space for a beginning. In the centuries and millennia that followed, new forms of life began to fill the empty spaces left by the dinosaurs. The tiny mammals, no longer suppressed by the fear of predation, emerged from their burrows. They began to grow larger. They diversified into a vast range of species: herbivores, predators, swimmers, climbers, and eventually, primates. The ecosystems that replaced the age of reptiles were smaller at first, quieter, more diverse in different ways. It was as though the world had chosen a new rhythm, gentler, but no less full of life. The heavy, thundering footsteps of the sauropods were replaced by the soft padding of paws. Scientists studying the Chicxulub crater today use massive drill ships to bore down through the ocean floor, reaching the buried layers of impact rock. These cylinders of stone are like time machines. These rocks record the seconds and hours after the event with astonishing detail. They contain melted glass, shocked quartz with crystal structures deformed by pressure, and tiny spheres of condensed vapor called tektites. Each fragment tells a specific part of the story. One layer shows the sudden rise in temperature. The next shows a flood of molten debris. Then, layers of chaotic sediment from the tsunamis. And finally, the slow settling of fine clay, cooling, condensation, and calm. Even the boundary layer itself, that thin stripe of clay found by the Alvarezes, is a time capsule. It contains particles of soot from the global fires, microscopic diamonds formed in the shock pressure, and fossil pollen frozen in transition from one world to another. When you hold a piece of KPG boundary rock in your hand, you are holding the physical manifestation of a turning point. You are holding the moment when life changed direction. It is a humble-looking rock with a profound weight. Scientists can even estimate how long the darkness lasted using complex climate models. These simulations suggest that sunlight was reduced by up to 90% for several months, with global temperatures dropping as much as 15 to 20 degrees Celsius. Afterward, as the dust cleared, the Earth entered a greenhouse phase. The carbon dioxide released by vaporized rock and widespread fires thickened the atmosphere, trapping heat. The Earth went from a freezer to a sauna. Heavy rains fell for centuries, flushing the toxins from the soil and sea. Through it all, the planet's systems sought balance. The carbon cycle, the water cycle, the nitrogen cycle. These planetary gears kept turning, slowly repairing the damage. In a way, the Earth behaves like a living organism, a Gaia system. When disturbed, it reacts. When hurt, it heals. It creates new complexities to replace the old. The layers of rock that hold this record are not just scientific data, they are memories. The Earth remembers everything. It remembers the fire, the ice, the silence, and the song. We are walking on a library of these memories, buried just beneath our feet. And when we read these memories, we learn not only about extinction, but about endurance. We learn that life is not a fragile thing that vanishes at the first sign of trouble. It is a force, a relentless drive to exist. The impact may have erased the non-avian dinosaurs, closing the book on their magnificent 150 million year reign, but it did not erase life's determination. That same determination would, millions of years later, give rise to the intelligence that is now piecing their story together. Rate 100%, pitch 1%. We are the beneficiaries of this disaster. We are the children of the asteroid. The very existence of the human mind is a direct result of the chain of events set in motion by that falling rock. In the next chapter, we will step away from the prehistoric world and explore the human side of this discovery. We will explore how that intelligence, human curiosity, uncovered this event from deep time. We will look at how geologists, paleontologists, and astronomers collaborated, argued, and researched to solve one of the greatest mysteries in science. What really happened the day the dinosaurs disappeared? It is a detective story that spans the globe. For now, let your imagination rest on the image of the world in twilight. The skies are dimmed, the forests are quiet, but the danger has passed. The first green shoots of ferns are beginning to rise through the ash, uncurling their leaves toward the returning sun. It is a planet slowly remembering how to live again. We enter the detective story that took humanity more than a century to solve. For most of human history, the extinction of the dinosaurs was a mystery wrapped in silence. The fossils told a story of life long vanished, skeletons of creatures larger than anything alive today. Bones turned to stone and scattered across the world like a cryptic alphabet. But how these animals had disappeared and why remained unknown, a puzzle with half the pieces missing. In the 19th century, when paleontology first began to take shape as a science, the very idea of extinction was radical. Men in tweed coats walked along the rocky coasts of England, finding massive vertebrae in the cliffs, and wondered if these dragons still roamed some unexplored corner of Africa or South America. Most scientists of that Victorian era believed in a slow, orderly world. They adhered to the principle of uniformitarianism. the belief that the forces shaping the Earth today are the same gentle forces that shaped it in the past. Erosion, sedimentation, the slow drift of continents. To them, extinction was a gradual fading, a slow replacement of one form of life by another, like the changing of the guard. The idea that a single day could end an entire era seemed impossible. It felt too chaotic, too random, perhaps even too terrifying to contemplate. It suggested that the Earth was not a safe garden, but a vessel adrift in a dangerous universe. Even as new fossils were uncovered in the American West, revealing the true scale of the dinosaur empire, the pattern of their disappearance was not immediately clear. The fossil record is a fickle narrator. It has gaps and blurred edges. Some believed changing climates had slowly frozen the giants. Others thought falling sea levels had dried up their swamps. There were stranger theories too. Some Victorian scholars suggested that small mammals had begun eating the dinosaurs' eggs, a slow attrition of the next generation. Others thought volcanic eruptions had poisoned the air over millions of years, or that a great plague had swept across the supercontinents. All these theories contained part of the truth, fragments of a larger picture, but the key, the single unifying explanation, was still hidden. It was waiting quietly in the rocks themselves, locked in a language we had not yet learned to read. The breakthrough began, as many profound discoveries do, not with a shout of "Eureka!" but with a quiet moment of curiosity. It began with a question asked in a limestone gorge in Italy. In the late 1970s, a team of scientists traveled to the Apennine Mountains near the medieval town of Gubbio. This region is famous for its scaglia rossa, a pinkish limestone that was once the floor of an ancient deep sea. The rock layers there are like the pages of a book, perfectly preserved, recording millions of years of history in colorful stripes. The team found something strange in the rock face. Between massive layers of limestone, which were filled with the microscopic fossils of Cretaceous sea life, they discovered a thin band of clay. It was only a few centimeters thick, a dull gray stripe in the wall of pink stone. But this clay was different. It was completely devoid of life. Below it, the rocks were teeming with the diversity of the dinosaur age, tiny foraminifera that had thrived in the warm oceans. Above it, the fossils were different, smaller, scarcer, a completely new cast of characters from the Paleogene period. The clay was a boundary line. It was a door that had slammed shut. The team included the geologist Walter Alvarez and his father, the Nobel Prize-winning physicist Luis Alvarez. It was a meeting of two minds, the geologist who looked at the Earth and the physicist who looked at the atoms. They stood in the gorge, running their fingers over that thin layer of gray clay. They wondered, how much time did this layer represent? Was it a sudden deposit, formed in a few years? Or was it a slow accumulation of dust over millennia, representing a long gap in the fossil record? To answer this, they needed a clock. They decided to measure the amount of iridium in the clay. Iridium is a platinum group metal, incredibly rare on the Earth's surface. Because it is heavy, most of Earth's iridium sank to the core when the planet was young and molten. However, iridium is common in space. It exists in meteorites and cosmic dust. Every day, a fine dusting of cosmic material falls gently onto our atmosphere. settling on the surface like invisible snow. It is a constant, steady background rhythm of the solar system. The Alvarez team reasoned that if they measured the iridium, they could tell how long the clay took to form. If the layer formed slowly over thousands of years, it would have collected a lot of cosmic dust, a high level of iridium. If it formed quickly, it would have very little. They took their samples back to the laboratory in California. They ran the tests, expecting a standard result. But when the numbers came back, they were shocking. The clay didn't just contain a little iridium. It contained huge amounts, 300 times more than the background level. It was an anomaly so large it made no sense in the context of normal geology. It was as if the cosmic clock had suddenly dumped 1 million years' worth of dust in a single instant. At first, their findings were met with deep skepticism. The scientific community is conservative by nature. It requires extraordinary proof for extraordinary claims. The idea that an asteroid, a rock from space, could cause a mass extinction sounded too dramatic. It sounded like science fiction, not serious geology. But Walter and Luis Alvarez persisted. They published their hypothesis in 1980, suggesting that a massive asteroid, perhaps 10 kilometers wide, had struck the Earth. They calculated that such an impact would throw enough dust into the atmosphere to block the sun and stop photosynthesis. Over time, the evidence grew undeniable. Other scientists began checking the KPG boundary, that same geological timeline, in other parts of the world. They looked in Denmark. They looked in New Zealand. They looked in the bottom of the Atlantic Ocean. That iridium layer was not unique to Italy. It appeared everywhere. It was a global signature. It was a chemical fingerprint wrapped around the entire planet, a shroud of dust that had settled after a singular, terrible day. Eventually, the physics became impossible to ignore. They calculated that only an impact of unimaginable scale, an explosion equivalent to millions of nuclear weapons, could have vaporized an asteroid and distributed that much iridium across the entire surface of the world. Still, a massive piece of the puzzle was missing. If a mountain-sized rock had hit the Earth, where was the hole? Where was the crater? A collision of that magnitude should have left a scar visible from the moon. For a decade, the crater eluded discovery. Researchers searched in vain across the continents. They looked for circular lakes, for shattered mountain ranges. They scanned the ocean floors with sonar. There were false leads, a structure in Siberia, a crater in Iowa. But none were the right age or the right size. It seemed the Earth had hidden the evidence. Perhaps the crater had been subducted, swallowed by the slow movement of tectonic plates, and melted back into the mantle. The theory was in danger of remaining just a theory, an unproven ghost story. It was finally oil geologists in Mexico who found it, and they found it not through paleontology, but through gravity. Decades earlier, in the 1950s, the Mexican oil company Pemex had been mapping the subsurface rock layers beneath the Yucatan Peninsula, looking for petroleum traps. Rate 100%, pitch 1%. While scanning the magnetic and gravitational fields, they noticed an enormous circular anomaly buried deep beneath the limestone and the jungle. It was a perfect ring, more than 150 kilometers wide. Something deep below the surface had altered the density of the crust, creating a heavy, dense ring of rock. At the time, the data was classified, locked away in corporate archives. But in the early 1990s, a geologist named Glenn Penfield, who had seen the old maps, managed to connect the dots. He realized that this structure was not a volcano. It was an impact crater. When the Alvarez hypothesis and these geophysical maps were finally brought together, the two lines of evidence fit perfectly like a key in a lock. The mystery had a location. The killer had left a fingerprint in Italy, but the body was buried in Mexico. The Chicxulub crater had been hiding in plain sight all along. In fact, the local Mayan people had lived on top of it for thousands of years. The Yucatan Peninsula is dotted with cenotes, deep, freshwater sinkholes considered sacred portals to the underworld by the Maya. If you look at a map of these cenotes, they form a massive semicircle. They trace the fault lines of the buried crater rim. The sacred geography of an ancient civilization was actually outlining the scar of a cosmic catastrophe. Once confirmed, the pieces of the story fell together with quiet inevitability. The scientific community, once skeptical, watched as the data converged into a single, undeniable truth. The layer of iridium was the fingerprint of the asteroid itself. The shocked quartz, tiny crystals found in the rock that were fractured by pressure far beyond any volcanic force, was the signature of the blast. And the crater, buried beneath kilometers of white limestone and blue sea, was the final proof. From that point, scientists began reconstructing the event with remarkable detail. Using supercomputers and physics, they calculated the speed of impact. Using chemistry, they determined the sulfur and carbon released into the air. Using biology, they measured its effects on the food web. What emerged was a picture both violent and beautiful. An entire planet responding to a single instant of trauma. It shifted our understanding of the Earth from a closed, gradual system to an open, dynamic one, vulnerable to the chaotic billiards of the solar system. The story of that discovery is one of patience. It took not one generation, but several. It required the Victorians to find the bones, the mid-century physicists to understand the atoms, and the modern geologists to map the gravity. It involved scientists working across continents, from the cold cliffs of Denmark to the tropical jungles of Mexico. It was a triumph of the human method, observing, hypothesizing, arguing, and eventually finding the truth guided by evidence rather than assumption. In that sense, the science itself mirrors the Earth's own recovery after the impact. Slow, steady, persistent, guided by the search for balance. Just as life returned to the crater, understanding returned to our history. Each discovery added another layer of texture to the picture. Tektites, tiny beads of glass created when molten rock is thrown into space and freezes before it lands, were found embedded in rocks across the Caribbean. They look like small, black teardrops of glass. Marine sediments showed abrupt changes in plankton populations. 1 millimeter of rock is full of diverse life. The next millimeter is barren. Tree pollen vanished from the fossil record almost instantly, replaced by a spike in the spores of ferns and fungi, the disaster flora that thrives on rotting vegetation. The pattern was consistent everywhere. The planet had experienced a sudden and profound shift. The old world didn't fade away, it was turned off. With this massive accumulation of evidence, the old idea of uniform, gradual change gave way to something more dynamic. Evolutionary biologists call it punctuated equilibrium. It is the idea that life usually changes slowly, but occasionally it is forced to leap. Life, it turned out, sometimes advances not in smooth lines, but in sudden breaks and recoveries. The history of life is not a ramp, it is a staircase, and the dinosaurs' extinction was one of the steepest steps. Even as the asteroid theory triumphed, the scientific picture continued to gain nuance. Some scientists pointed out that the Earth was already under stress before the rock hit. In what is now India, massive volcanic eruptions, known as the Deccan Traps, were occurring. These were not normal volcanoes, but floods of lava that lasted for tens of thousands of years, covering an area the size of France. They were releasing vast amounts of carbon dioxide and sulfur into the air, warming the climate and stressing the ecosystems. Perhaps the dinosaurs were already weakening. Perhaps the asteroid was simply the final blow, the coup de grace that toppled a teetering system. Whether through impact, eruption, or a deadly combination of both, the outcome was the same. Earth was irrevocably changed. Evolution took a new direction. The roll of the dice came up in favor of the small, the furry, and the adaptable. That new direction would eventually lead to mammals, to primates, to the first tool users, and finally, to consciousness capable of wondering how it all began. It is a humbling thought to realize that we owe our existence to events far beyond our control. We are here because of a collision that happened 66 million years ago. We are here because of the trajectory of a rock that formed near Jupiter. The scientists who uncovered this story often speak not of destruction, but of awe. In their notes and interviews, there's a quiet reverence. They understand that they are reading the autobiography of a planet. They are the first species to read the pages of the book that was written before they were born. To hold a piece of the iridium layer in one's hand, that thin gray clay, is to touch the meeting point between Earth and space. It is a tangible connection to the cosmos. It is a reminder that our world is not an isolated bubble, but part of a vast, interconnected system. The same processes that formed the stars also formed the asteroid. The same elements that once burned in its core, iron, iridium, nickel, now live in our own soil, our own tools, even our own blood. We are made of the debris of the universe. Science, when told with patience, becomes not just knowledge but perspective. It heals the separation between us and the past. It shows us that endings and beginnings are woven together, strands in the same great tapestry. In the fossils of dinosaurs and the rocks of the crater, we can read that continuity. We see how one day reshaped an entire planet, and how time itself softened the edges of catastrophe into balance. The horror of the event has faded, leaving only the lesson. Even now, at the site of Chicxulub, life thrives. If you go there today, you will not see a wasteland. You will see the turquoise Caribbean Sea. Coral reefs, colorful and vibrant, grow on the ridges of the buried crater. Schools of fish swim through the water that once boiled. Tropical storms pass overhead, the clouds swirling in the same atmosphere that was once choked with ash. The jungle grows thick and green over the limestone that hides the scar. The ocean covers what once burned, and peace has returned. There is something deeply comforting in that. It tells us that the earth remembers, but it also forgives. It does not hold on to the trauma forever. It works tirelessly to cover the wounds with green. It turns, always, toward renewal. It chooses life over and over again. In the next chapter, we will explore that renewal itself. We will watch the curtain rise on the Cenozoic era. We will see how life rebounded in the wake of extinction, how ecosystems reinvented themselves in the absence of giants, and how the quiet survivors of that day became the ancestors of everything alive today. For now, let your mind rest with the scientists. Imagine them kneeling in sunlit fields in Italy or Mexico, brushing the dust from ancient stones. Hear the scratch of their tools and the whisper of the wind. Feel the weight of deep time in their hands, uncovering not just fossils, but the deep, steady rhythm of the planet's memory. After the darkness, there was light again. It did not return all at once, like a lamp being switched on in a dark room. It came slowly, hesitantly, filtered through layers of thinning ash and dissipating clouds. It was pale at first, a watery gray dawn that lasted for years. But eventually, the sun reclaimed its golden strength. The air, once choked with sulfur and soot, began to warm. The rains, which had fallen as acid for so long, softened into sweet, nourishing showers. And life, patient and quiet, began its return. It is a moment of profound relief, a planetary exhalation after holding its breath for too long. When we speak of recovery after extinction, it is easy to imagine a world that remained barren and lifeless for eons, a desolate wasteland of gray rock and mud. But this is not the case. Even in the deepest shadow of catastrophe, the planet remained full of possibility. Life is not easily extinguished. It is tenacious, stubborn, and endlessly inventive. Beneath the soil, seeds had waited. This is one of nature's most brilliant designs: dormancy. Seeds are essentially time capsules, tiny biological bunkers wrapped in hard coats, capable of shutting down their metabolic processes and waiting for the signal to wake. They lay in the dark, cold earth, ignoring the fires above, holding the genetic blueprints of the future forests within them. In rivers and burrows, small animals had endured. While the giants starved on the surface, the scavengers survived below. Microbes, invisible yet essential, continued their ancient work of turning matter back into life. In fact, the immediate aftermath of the extinction saw a strange phenomenon known as the fungal spike. For a brief time before the plants returned, the world was ruled by fungi. They bloomed on the decaying matter of the fallen Cretaceous world, knitting the soil together with their white threads, breaking down the dead to make way for the living. They were the recyclers, preparing the stage for the next act. The Earth, like a living organism, began to heal itself. It has mechanisms of repair that operate on timescales we can barely comprehend. The carbon cycle, the water cycle, the flow of nutrients. These planetary gears began to turn again, flushing out the toxins and rebalancing the atmosphere. The first signs of visible renewal appeared within decades. It started with the ferns. Ferns are the pioneers of the plant kingdom. They do not need insects to pollinate them, nor do they need perfect soil. They spread via spores, microscopic dust that can travel on the wind for thousands of miles. Across the burned, charcoal-black landscapes of North America and Asia, green shoots began to unfurl. They formed lush, emerald carpets over the ash. These disaster taxa, as paleontologists call them, thrived where others could not. They stabilized the ground, preventing erosion, and created a humid microclimate for other plants to follow. Over time, the monochrome world of black ash and green ferns began to diversify. New forests emerged from the seed banks. Palm trees, with their broad fronds, reached for the sun. Magnolias, an ancient lineage of flowering trees, opened their large, fragrant blossoms. What had once been a scene of absolute destruction became fertile ground for evolution. The ash itself, rich in minerals, fed the new growth. The destruction of the old canopy allowed light to reach the forest floor, triggering a race for the sky. The world was being repainted, leaf by leaf. Many of the great dinosaurs were gone forever. The Triceratops, the Tyrannosaurus, the long-necked sauropods, they had vanished into the rock, leaving only their bones as monuments. Yet, the lineage they left behind, the birds, filled the skies with new songs. The birds that survived were likely ground dwellers, similar to modern quails or ducks. They had survived because they could eat seeds and didn't rely on living trees, which had largely burned down. Now, with the skies empty of pterosaurs, they radiated into new forms. Small, feathered survivors carried ancient instincts into a changed world, their calls echoing over the regenerating forests. On land, mammals began their quiet rise. This is the chapter of history that belongs to us. Before the impact, our ancestors had lived mostly in the shadows. They were small, nocturnal creatures, rarely larger than a badger. They lived in fear, scurrying through the undergrowth, avoiding the gaze of the giant reptiles. But now, the monsters were gone. The forests and plains were open, and evolution had room to breathe. The ecological shackles were broken. The night dwellers stepped into the daylight. They blinked in the sun, sniffing the air of a world that was suddenly theirs to conquer. Within a few million years, a geological blink of an eye, these once tiny mammals diversified into an explosion of new forms. They grew larger. They specialized. Some became grazers, developing flat teeth to chew the tough leaves. Others became predators, developing sharp claws and keen senses to hunt the grazers. The first ancestors of primates appeared, creatures like Purgatorius, small, tree-dwelling beings with grasping hands and forward-facing eyes. So did the early relatives of whales, elephants, and horses. The diversity was staggering. Nature was experimenting, throwing shapes against the wall to see what would stick. Each generation adapted a little more to the new world that was forming. The heavy, humid air of the Paleogene period supported dense rainforests that stretched from the equator almost to the poles. It was a hothouse Earth, a tropical paradise where reptiles like crocodiles and giant snakes could grow to immense sizes in the heat. The fossil record of this time shows remarkable creativity in nature. We see mammals with strange combinations of features, hooves and claws, long tails and heavy skulls. Shapes and strategies never seen before began to appear. Life was improvising, playing jazz in a biological key. The oceans followed a similar path of resurrection. At first, in the months after the impact, they were dark, cold, and acidic. The Strangelove Ocean, as scientists call it, was almost devoid of life, but as sunlight returned, the engine of the sea restarted. Plankton, the microscopic algae and animals that float in the upper layers, began to bloom again. These organisms are the unsung heroes of the biosphere. They capture the energy of the sun and turn it into food. Their return meant oxygen for the atmosphere and a base for the food web. Their return signaled the recovery of the biological pump, drawing carbon down from the atmosphere and burying it in the deep sea. The chemistry of the water normalized. Fish populations rebounded. Coral reefs, the rainforests of the sea, rebuilt themselves, layer by calcified layer. New species of mollusks and crustaceans evolved, filling the roles once held by ammonites. The same forces of natural selection that had once shaped the marine reptiles now worked quietly beneath the waves, sculpting whales from land-walking ancestors who returned to the water to find food. This period, known as the Paleogene, was an age of radical renewal. Volcanoes and shifting continents continued to sculpt the planet's surface, pushing up the Rocky Mountains and the Himalayas, but the biological focus was growth. Forests thickened into megathermal rainforests. Rivers changed course, winding through vast floodplains. And eventually, the first true grasslands began to form, creating a new kind of habitat, open, sunny, and rich in energy. With them came insects, birds, and mammals perfectly suited to the wide open spaces. In many ways, the impact had reset evolution, not destroyed it. It acted like a forest fire on a planetary scale. It cleared out the old growth, the established giants that were hoarding the resources, and cleared the stage for new actors. When paleontologists study these early fossils, they often find traces of resilience in their forms. They find bones that healed from breaks, species that spread rapidly across continents, and ecosystems that rebalanced in ways no one could have predicted. It is a lesson in plasticity, the ability of life to mold itself to new conditions. Life, it seems, has an instinct for renewal. It pushes back against entropy. Where there is energy, life will find a way to use it. Where there is space, life will find a way to fill it. Even after the most extreme events in Earth's history, the freezing of the globe, the poisoning of the oceans, the bombardment from space, the same pattern always follows: extinction, recovery, diversification. A collapse is followed by an explosion of creativity. This rhythm is built into the planet's DNA. It is the heartbeat of the biosphere. Destruction and creation are not opposites. They are partners in the dance of existence. Without the death of the dinosaurs, the Earth would have remained locked in the Cretaceous patterns. For humans, it can be difficult to imagine such long spans of time. We measure change in years or decades, a human lifespan, but the Earth measures in millions. From that deep time perspective, what feels like an ending, the asteroid strike, becomes only a pause between movements in a symphony. If we compress the planet's history into a single calendar year, the asteroid strike would have happened just a few days before December 31st, roughly around December 26th. And yet, in those final days of the calendar, everything that would become our modern world began to form. As mammals diversified, their brains grew more complex relative to their body size. New behaviors appeared: social groups, care for young that extended for years, communication through sound and complex scent marking. These were the small beginnings of what, much later, would become intelligence. The world that emerged after the dinosaurs was quieter, perhaps, lacking the earth-shaking thuds of the sauropods, but it was more intricate. Instead of giant bodies, evolution began to favor adaptable minds. It favored those who could solve problems, those who could remember where the food was hidden. This shift can be seen even in the plants. Forests became layered and diverse, offering new kinds of shelter and food. Flowering plants spread widely, co-evolving with insects to create the complex pollination networks we see today. The world became more fragrant, more colorful. Pitch 1% everywhere. Balance returned, different from before, but equally alive. The food webs reconnected. The predators kept the prey in check. The plants supported the insects. The fungi recycled the dead. The circle closed again. One of the most fascinating ideas in modern biology is that mass extinctions, while tragic for the individuals who die, may also accelerate evolution. They act as a pulse of change. When competition disappears, surviving species adapt quickly, filling empty roles in a phenomenon called adaptive radiation. Without the dinosaurs, mammals expanded in size and intelligence. Without the old forests, new ones grew with different strategies for capturing light and storing water. The deck was shuffled, dealing a new hand to the survivors. The Earth, like an artist, used the materials of the past to create something new. It took the bones of the old world and built the foundation of the new one. The limestone that formed from the shells of dead plankton became the bedrock of future continents. Eventually, after millions of years, the climate stabilized. Temperatures warmed again, peaking in the Eocene, and the atmosphere reached a new chemical balance. By then, the memory of the impact existed only in stone, a thin line of iridium buried deep underground. Fossils of early primates appear around this time, small, tree-dwelling creatures with large eyes for judging distance and grasping hands for holding branches. They lived in the canopy of these new rainforests. Their descendants, our ancestors, would one day look back on all of this and tell its story. It is remarkable to realize that our existence, our every breath, is the distant echo of that single day in the late Cretaceous. If the asteroid had missed, if it had arrived 20 minutes later or earlier, it might have hit the deep ocean, absorbed by the water. The dinosaurs might have survived. The asteroid made room for us. Not by intent, the universe does not have intent in that way, but by the mathematics of nature, where destruction and creation are parts of the same equation. We are the lucky inheritors of a planet cleared for our arrival. Earth's ability to recover is not a miracle. It is a process. It is physics and chemistry and biology working in concert. Energy cycles through matter, and matter reshapes itself through time. From molecules to mountains, everything renews. When the dinosaurs vanished, it might have seemed to an observer like the end of all life. The silence must have been terrifying. But the same sunlight that had once warmed their scales continued to shine. It simply found new forms to touch: fur, feathers, and leaves. Pitch 1%. Even today, when we see birds flying at dusk, silhouetted against the setting sun, we are seeing survivors of that lineage. We are seeing the descendants of creatures that once shared the sky with pterosaurs. They are living dinosaurs, carrying the torch of their ancestors. In their flight, there is continuity. In the way a robin hunts for a worm, there is an echo of the raptor hunting its prey. The past is never truly gone. It is just folded into the present. And in our curiosity, there is remembrance. By studying the rocks, by asking questions, we honor the history of our home. We acknowledge that we are part of a long, unbroken chain of life. The story of recovery after the asteroid reminds us that the planet is resilient beyond measure. It bends, but does not break. It transforms, but it never truly ends. It is a self-correcting system, beautiful and terrifying in its power. In the next chapter, we will explore what this event can teach us about our own future. We will look at how understanding the past helps us see our place in Earth's long story. We will examine how the same cycles of change, carbon, climate, and extinction, continue even now, written in the chemistry of the air and the stars. For now, let your imagination rest on that ancient world reborn. Picture the green shoots breaking through the gray ash. Hear the sound of rivers flowing clear again. See the first mammals emerging from their burrows into the sunlight of a new Earth. A world rediscovering its rhythm. A planet remembering how to live. Now, we stand on the shore of the present, looking back across the ocean of time to ask, what did that moment truly mean? The asteroid that ended the age of the dinosaurs is long gone. The rock itself was vaporized in the violence of its arrival, becoming part of the atmosphere, part of the soil, part of us. The crater, that vast wound in the crust, lies buried under kilometers of sea and limestone. Yet its lesson remains written across the face of the earth, legible to those who know how to read the language of stone. Every continent, every ocean carries traces of that day. If you were to dig deep enough in the clay of New Zealand or chip away at the cliffs of Denmark, you would find it. Microscopic particles of iridium, stardust from a distant collision, still rest in ancient sediments. They are the silent witnesses of a cosmic intervention. But the legacy is not just mineral. The patterns of evolution that followed can be read in every fossil, every feather, every living creature that draws breath today. The shape of a bird's wing, the complex folding of the human brain, the way a forest reorganizes itself after a fire. All these are echoes of the Great Reset. The story is not one of loss alone, but of renewal, of how life adapts, reorganizes, and invents new solutions after catastrophic change. It is a masterclass in resilience, taught by the planet itself. In the long, deep memory of the planet, catastrophe and recovery are partners. They are not enemies. They are the two hands that shape the clay of existence. Where one ends, the other begins. Destruction clears the canvas. Creation paints the new picture. When scientists study the extinction of the dinosaurs, they are not only reading history, they are reading Earth's own capacity for healing. They are studying the immune system of the biosphere. It is easy to think of the past as distant, sealed away in time like a specimen in a glass jar. But the forces that shaped that ancient day are still with us now. They are the fundamental laws of our reality. Gravity still pulls with the same relentless consistency. Asteroids still move through the silent dark of space, dancing their orbital waltzes. Volcanoes still breathe fire from the depths, knitting new land from molten rock. And life still finds its way through it all. The persistence of biology is the dominant theme of our planet's song. The impact that reshaped the world also reshaped the balance of energy on the planet. It demonstrated the fragility and the power of the climate system. Dust cooled the atmosphere by reflecting sunlight, creating a false winter. Then, Carbon dioxide warmed it again, trapping heat like a blanket. The same cycles of cooling and heating, of balance and disruption, continue today. To understand the extinction is to understand the climate, how delicate the web of sunlight, air, and life truly is. It teaches us about albedo, the reflectivity of the Earth. When the asteroid hit, it changed how the Earth reflected light. When sunlight was blocked by the clouds of debris 66 million years ago, the primary engine of life, photosynthesis, stopped. This is the foundation of the biological pyramid. Without plants to turn solar energy into sugar, the herbivores starved. Without herbivores, the predators soon followed. The collapse moved upward through every layer of the food chain in what scientists call a trophic cascade. It was a domino effect of tragic proportions. It is a stark reminder of how connected life is, and how quickly that connection can fray when the foundation is shaken. Modern scientists studying climate change sometimes look to this event as a guide. They look to the Paleocene-Eocene thermal maximum that followed to understand how life reacts to rapid warming. Not because history repeats itself exactly, but because it rhymes. It reveals how the Earth responds to imbalance. When the energy budget of the planet changes, whether blocked by cosmic dust or trapped by greenhouse gases, the entire system reacts. The oceans change their chemistry. The currents shift their paths. The forests migrate toward the poles. But the Earth, as history shows, also finds equilibrium again. This is the concept of homeostasis. The planet seeks a steady state. After the asteroid, balance took time, centuries for the dust to settle, millennia for the carbon to be reabsorbed, millions of years for diversity to return. But it returned. The healing was slow, but it was absolute. New systems emerged, adapted to the changed conditions. That adaptability is one of life's greatest strengths. It is the ability to bend without breaking. In every species that survived, from the smallest birds to the shrew-like mammals to the hardy conifers, we can see patterns of resilience written in their biology. We can see the tools of survival. Feathers, originally evolved for display or insulation in dinosaurs, became the key to survival for birds, trapping body heat in the cold darkness. Seeds developed dormancy, a physiological state of waiting, allowing them to sleep through the apocalypse and wake up in the spring of a new era, and brains, specifically mammalian brains, grew larger. The chaos of the post-impact world favored intelligence. It favored the problem solvers. The neocortex, the outer layer of the brain responsible for complex thought and sensory processing, began to expand. Creatures needed to remember where food was hidden in a changing landscape. They needed to process sounds in the dark. They needed to adapt their behavior instantly, not over generations. The pressure of the extinction event forged the neural pathways that would eventually lead to us. Even the human story begins here, in the ashes of the Cretaceous. Our ancestors, small mammals living in the shadows of the dinosaurs, inherited that instinct to endure. We are the children of survivors. That drive lives still in our minds and movements, the urge to adapt, to rebuild, to continue. When we feel anxiety about the future, we are feeling the ancient alert systems that kept our ancestors alive. When we plan for tomorrow, we are using the neocortex that expanded to solve the problems of a broken world. When we face challenges today, environmental, personal, or global, We are participating in the same process that began with that impact. We are part of the lineage of resilience. Change arrives suddenly. It disrupts the status quo. Then, slowly, painfully, life reorganizes around it. It finds a new normal. The Earth has always moved through cycles of destruction and renewal. Mountains rise due to tectonic pressure, only to be eroded by wind and rain into fertile soil. Oceans expand as continents drift, only to contract and vanish millions of years later. Species appear, have their moment in the sun, and vanish, only for new ones to take their place in the ecological niche. It is a constant, fluid dance. From the perspective of deep time, this is balance. It is not chaos, though it feels chaotic when you are in the middle of it. It is the steady recalibration of a living world. It is the planet breathing in and breathing out over eons. We are part of that world, not separate from it. We often view ourselves as observers of nature, but we are nature. Our own systems, our societies, our technologies, even our emotions, follow similar patterns of growth, collapse, and renewal. Moments of collapse often lead to new ideas, new forms, new life. Just as the loss of the dinosaurs made room for the mammals to rise, loss in human history often creates space for transformation. The forest fire clears the brush to allow the saplings to grow. There is comfort in that pattern. It takes the senselessness out of tragedy. It means that change, even when violent and sudden, can carry purpose. It leads to something. Science gives us the tools to see these connections clearly. It gives us the data, the chemistry, the physics. But wonder allows us to feel them. Wonder allows us to internalize the lesson. Imagine standing on the shore of the Yucatan Peninsula today. The sun is hot on your skin. The waves of the Caribbean move softly over the limestone shelf, turquoise and clear. The wind carries the scent of salt and sun-baked rock. Beneath your feet, deep below the white sand and the coral roots, lies the scar of the impact. The peak ring of the crater forms a circle of mountains buried under the ocean floor. It is silent now, covered by coral and time. The same place that once burned brighter than the sun, the ground zero of the apocalypse, is now a calm ocean teeming with colorful fish. Barracudas patrol the reefs. Sea turtles graze on the seagrass. Life has reclaimed what was lost. It has built a paradise on top of a graveyard. This transformation, from absolute violence to absolute peace, is one of nature's quiet miracles. It brings to mind the Japanese art of kintsugi, repairing broken pottery with gold, making the object more beautiful for having been broken. The Earth is a kintsugi planet, veined with the gold of recovery. When scientists drill into the crater today, pulling up long cylinders of rock, they find layers of limestone filled with fossils, shells, algae, coral, proof that the sea not only returned but flourished. They find the microscopic skeletons of coccolithophores, tiny algae that bloomed in the millions, their calcium shells sinking to the bottom to create the chalk that defines the age. The famous White Cliffs of Dover are, in a way, a monument to this recovery, huge piles of life that thrived in the new oceans. It is a story of patience. Earth does not rush its healing. It does not work on human deadlines. It allows time, and through time, recovery becomes inevitable. Perhaps this is a lesson for us in our hurried, anxious lives. That renewal cannot be forced, only allowed. That sometimes the only thing to do is wait for the dust to settle, for the rain to fall, for the seed to open. When we face our own disruptions, whether in nature or in our personal lives, we can look to the planet's history for guidance. We can trust the process. After fire, new growth. After darkness, new light. After endings, new beginnings. This is the mantra of the biosphere. The asteroid story, seen through the lens of science, is the planet's way of saying change is inevitable, but destruction is temporary. Life is the permanent feature. In the cycles of geology and evolution, everything is repurposed. Nothing is wasted. The law of conservation of energy tells us this: energy cannot be created or destroyed, only transformed. Matter becomes energy. Ash becomes soil. Death becomes life. The giant fern that died in the fires became the coal that fueled the future. The calcium from the bones of the Tyrannosaurus dissolved into the water to build the shell of a nautilus. Even we, in our brief existence, are made of those same recycled atoms. We are forged in ancient stars, carried through oceans, reborn through time. The iron in your blood is the same iron that existed when the asteroid hit. The carbon in your breath once floated in the Cretaceous air. The dinosaurs' world may have ended, but their atoms did not vanish. They became part of everything that followed. They are woven into the tapestry of the present. In that sense, extinction is not erasure. It is transformation. It is the breaking of a form to release the material for a new form. Every generation of life inherits the remains of the one before. We stand on the shoulders of giants, literally. The soil we walk on is a compost of history. We are all, in the deepest scientific sense, connected to the day the dinosaurs disappeared. Our story began in their ending. Their exit opened the door for our entrance. We are the silver lining of their cloud. Imagine diving into one of the cenotes in Mexico today, those freshwater pools that trace the crater's edge. The water is cool and crystal clear. Shafts of sunlight pierce the darkness, illuminating the roots of trees that drink from the water. It is a cathedral of silence. Swimming there, suspended in the water, you are floating in the exact spot where the world changed, but there is no fear there, only a profound stillness. The violence has been metabolized by the earth into beauty. When we look up at the night sky and see the stars, the same stars that once shone over the Cretaceous world, we are reminded that creation and loss exist side by side, eternal and inseparable. The universe is a place of violent collisions and silent births. In the next and final chapter, we will step back one last time. We will move from the lessons of the earth to the perspective of the cosmos. We will reflect on what this event tells us about the larger rhythm of the universe, about impermanence and wonder, and about the peace that comes from understanding change. For now, imagine the ocean over the Yucatan, calm, endless, and blue. Watch the waves roll in, one after another, breathing against the shore. It is hiding within its depths a memory not of destruction, but of survival. We have stood in the lush forests of the Cretaceous, watched the sky turn to fire, and witnessed the slow, green miracle of recovery. Now, we step back. We pull the camera away from the Earth, drifting upwards into the velvet silence of space to see the story in its entirety. The story of the dinosaurs' disappearance ends not in silence, but in light. From a distance, from the scale of the stars, it is only one event among countless others in the grand theater of the universe. In the time it takes to tell this story, stars have been born in the nebulae of Orion, and ancient suns have collapsed into white dwarfs in the center of the galaxy. Asteroids collide, worlds form from swirling disks of dust, solar systems dissolve and reassemble. It is a dynamic, violent, and beautiful dance that has been playing out for 13.8 billion years. Yet here, on this small, blue-green planet orbiting an ordinary yellow star, that single collision changed everything. It was a localized event with universal consequences for us. It shifted the trajectory of biology on Earth from a reptilian path to a mammalian one. It changed the face of the planet forever. It is humbling to realize how fragile life can seem when viewed against the backdrop of falling rocks and burning atmospheres. And yet, simultaneously, it is awe-inspiring to realize how persistent it truly is. One day, a fragment of rock, left over from the dawn of the solar system, fell from the sky. In an instant, it ended the reign of creatures that had dominated Earth for more than 150 million years. They were the masters of their world, seemingly invincible. And then, they were gone. And from that ending, from that smoking crater and that darkened sky, came everything that followed. The vacuum left by the giants was filled by the small: mammals, forests, flowering plants, songbirds, and, eventually, us. The chain of events is unbroken. Every breath we take carries the inheritance of that day. The oxygen in our lungs is produced by plants that evolved in the post-impact world. The structure of our brains was forged in the challenges of the recovery. We are, quite literally, the children of the asteroid. In the vast rhythm of the cosmos, extinction is not an accident. It is not a mistake. It is part of the same process that gives rise to life. It is the engine of change. Stars must explode as supernovae to scatter their heavy elements across the galaxy. Without those explosions, there would be no iron for our blood, no calcium for our bones, no carbon for our DNA. Planets evolve and collide to create new worlds. From the ashes of each event, new complexity emerges. The universe builds through transformation. It is a sculptor that never stops working, constantly refining its creation, breaking down the old to build the new. What seems like destruction at one scale, the tragic death of a triceratops, is creation at another scale, the opening of a niche for a primitive primate. The universe does not judge these events as good or bad. It simply moves forward. The asteroid impact that ended the dinosaurs' world was, in essence, the same cosmic process that once created Earth itself. 4.5 billion years ago, Earth was formed by the collision of countless asteroids and planetesimals. It was born in fire. Matter rearranging, energy redistributing, life continuing in new forms. This is the heartbeat of existence. Seen from this perspective, there are no true endings in nature. There are only transitions. There are only changes of state. Even death, when viewed through the lens of physics, is simply the transfer of energy. The first law of thermodynamics tells us that energy cannot be created or destroyed. It can only change from one form to another. The heat of the dinosaur's body became the heat of the soil. The atoms of its bones became the minerals of the rock. The spark of its life became part of the great flow of the biosphere. Nothing is ever lost. It is only borrowed and returned. When we step back and imagine the solar system as it was that day, it helps us understand this truth. Picture the silence of the void. the planets moving in their clockwork orbits silently, perfectly. The asteroid had circled the sun for millions of years before it met Earth. It was a faithful traveler, a silent stone in the dark. Its orbit was stable, tracing a path between Mars and Jupiter, perhaps for eons. Then, a small gravitational nudge occurred. Perhaps it passed too close to Jupiter, the giant of our system. Jupiter's immense gravity acts as a shepherd, pushing and pulling the asteroids. A tiny tug, a shift of a fraction of a degree. That single deviation, that microscopic change in vector, sealed the fate of the dinosaurs millions of years before the impact. It set the rock on a new course, spiraling slowly inward, destined to cross the path of the Earth at a precise moment in time. If the asteroid had arrived 20 minutes later, the Earth would have rotated slightly further. The rock would have struck the deep Atlantic or Pacific Ocean. The water would have absorbed much of the energy. The global fires might not have started. The dinosaurs might have survived. We might not be here. That idea, that vast change can emerge from the smallest motion, is one of the quiet wonders of science. It is known as the butterfly effect in chaos theory. The flap of a butterfly's wing in Brazil can cause a tornado in Texas. The nudge of a planet can end an era. It echoes through every level of existence, from the movement of galaxies to the unfolding of DNA strands in a cell. Small differences, repeated over time, create entirely new worlds. The dinosaurs could not have known their time was ending. They lived their days as we live ours, concerned with the immediate needs of food, safety, and family. They were unaware of the cosmic currents shaping their future. They did not look up at the stars with fear. They looked up with indifference. And yet, their legacy continues in ways they could never have imagined. They did not simply vanish into the void. Their bones became stone, preserving the shape of their lives for us to find. Their atoms became part of soil, sea, and sky. The carbon that once formed the spine of a stegosaurus may now be part of the tree outside your window, or part of the graphite in your pencil. We are walking on their dust. Their descendants, the birds, still fill the air with sound. Every time you hear a morning chorus, you are hearing the evolved voice of the dinosaurs. Their dominance of the land ended, but their mastery of the air continues. Even the asteroid itself, the agent of their destruction, is now part of the Earth. The iridium it carried is spread in a thin layer around the globe. The rock itself was melted, folded, and reborn in new minerals deep within the crust. It is no longer an alien invader. It is a citizen of Earth. Nothing is ever truly lost. The universe is a closed system. Everything that was here at the beginning is still here now, just arranged differently. When we understand this, the story of that violent day becomes a story of peace. It stops being a tragedy and starts being a chapter in a much longer book. The same energy that caused destruction also created opportunity. Nature abhors a vacuum. When the dinosaurs were removed, a massive ecological space opened up. Without that impact, evolution might never have turned toward intelligence, emotion, and reflection. The dinosaurs were successful, but they did not build telescopes. They did not write poetry. They did not wonder where they came from. We might never have looked up at the stars and wondered about our place in the cosmos. That capacity for wonder, that specific configuration of neurons that allows us to ask why is a direct result of the pressure placed on mammals to survive in a changing world. In a way, the asteroid's fall was the first step in a chain that would lead to consciousness itself. The universe destroyed a world of giants to create a world of thinkers. It destroyed the body to build the mind. This perspective does not diminish the loss. The millions of lives ended in fear and pain. The magnificent species, shaped by millions of years of evolution, that vanished in a blink. The vast forest that burned. It is a heavy weight to contemplate. But it frames that loss within the larger continuity of existence. It allows us to hold the grief and the gratitude in the same hand. Even destruction can serve creation when seen across the sweep of time. A forest fire clears the underbrush, releasing seeds that require heat to open. A supernova destroys a star system, but seeds the nebula with the ingredients for life. The same principle applies to us in our own short lives. Change, though often painful and unwelcome, opens space for renewal. When structures in our lives crumble, we are forced to build new ones. We are forced to adapt. Our own lives move through smaller versions of these cycles, moments of impact, periods of darkness, winter seasons of the soul, and, eventually, light. The Earth has shown us that light always returns. It is the promise written in the rotation of the planet. Every night is followed by a dawn. Every winter is followed by a spring. Every extinction is followed by a recovery. When we study the fossils, the craters, and the chemistry of that day, we are not simply studying history. We are learning how to live with change. We are learning the art of surrender to forces larger than ourselves. Science, at its most profound, teaches not only what happened, but how to accept what happens still. It teaches us that we are not the center of the universe, but we are a vital part of it. The extinction of the dinosaurs is a mirror. When we look into the dark glass of that event, we see our own reflection. We see our own fragility. We see our own dependence on the biosphere. It shows us that nothing is guaranteed. Not dominance, not size, not history. Yet it also shows us that everything is connected. It reminds us to see beauty even in impermanence. The dinosaurs were beautiful, and they are gone. That does not make their existence less meaningful. It makes it more precious. To understand that every moment, no matter how fleeting, carries meaning is the beginning of wisdom. The flower blooms for a few days, yet it is perfect. The dinosaur reigned for an era, and it was perfect. Perhaps that is the quiet gift the dinosaurs left us. Perspective, the gift of the long now, the ability to see beyond the headlines of today and look at the timeline of eons. To know that life endures, not because it resists change, but because it flows with it. Life is water, not rock. It moves around obstacles. It changes state. It evaporates and rains down again. The universe itself follows that pattern. Look up at the Milky Way on a clear night. It looks static, frozen in diamond dust, but it is churning. Stars live, die, and give their materials to the next generation. Our sun is a second or third generation star, built from the debris of ancient ghosts. Galaxies collide and merge, performing a slow gravitational ballet that takes billions of years to complete. Even space expands, stretching the light of ancient suns into the soft glow we call the cosmic background radiation. The universe is expanding, breathing out into the infinite. We are part of this same rhythm. Each of us is a brief expression of matter and energy, luminous for a time, complex and feeling, then returned to the whole. We are the universe waking up for a moment to look at itself. When we think of the asteroid now, we can see it not as a symbol of doom, but as a messenger. A harsh messenger, yes, but one that brings truth. It is a reminder that creation is inseparable from change. You cannot have the garden without the rain. You cannot have the mountain without the earthquake. It shows us that from endings come beginnings, and from loss, understanding. The darkness of the impact winter was necessary for the dawn of the Cenozoic era. The silence was necessary for the new song. Every time we look at a bird in flight, a heron standing still in the water, or a swallow darting through the air, we are seeing a survivor of that day. We are seeing a living thread connecting the past to the present. Their wings trace the same air that once burned with falling stone. Their hollow bones are the same architecture that built the T-Rex. Their songs are echoes of endurance, carried across 66 million years. If the dinosaurs could speak across time, perhaps their story would not be one of tragedy. Perhaps they would say, "We lived, we flourished, we shaped the earth, and now we are part of the earth." Their story would be of transformation, of being part of something larger and eternal. They played their part in the symphony, and the music continues. The earth itself seems to whisper that truth. If you listen to the sound of the wind in the canyons or the waves on the shore, it does not sound like mourning. It sounds like breathing. Through rock and water and wind, it reminds us, change is constant, but life persists. The planet is a self-correcting, self-healing miracle floating in the void. The stars above us burn with the same energy that shaped that day. Nuclear fusion, gravity, heat, light. And one day, they too will fade. Our sun will eventually expand, and then shrink, and then go dark. But even that is not the end. They will fade not into nothing, but into new forms of light and matter. They will become the nurseries for stars we will never see. The universe renews itself endlessly. It is a fountain that never runs dry. And so, when we listen to the story of the dinosaurs' disappearance, we are really listening to the story of everything. We are listening to the story of ourselves. We are seeing how creation moves through destruction, how loss becomes memory, and how memory becomes meaning. The past is the soil in which the present grows. In the end, that is the peace of it all. That is the comfort of the cosmic perspective. To understand that nothing stays, but everything continues, that life in every form is part of one endless, unfolding mystery. When the last dinosaurs vanished, taking their last breaths in the cooling twilight, they left behind not emptiness, but a pathway. They left a world ready for something new. And we are walking that pathway still. We are the travelers on the road they paved. Beneath us, the earth turns, calm now, blue and bright, shrouded in white clouds. It carries the memory of that ancient day quietly within its core, in the layers of rock that sleep beneath our feet. Above us, the stars shine, silent witnesses to every ending and beginning since time began. They watch over us with the same cold, beautiful indifference they showed the dinosaurs. And between them, between the rock and the stars, here we are. Life continues, learning, adapting, dreaming, just as it always has, just as it always will. This is the story of the dinosaurs' disappearance, not a tale of fear, but of continuity, not the end of life, but the turning of a page a peaceful look at a violent day, and at the eternal truth that every impact, every change, every loss is simply another way the universe learns to begin again. Rest now, in the safety of that cycle. Good night.